Welcome to this session on Gr10 CAPS, Trigonometry, and today we're going to find unknown angles where we've been given two known sides. So far we've calculated sides, given angles and a side, and also did the definition of sin, cos and tan. So we're doing something new and a bit strange today, and we're going to work with sin to the -1, which we call sin inverse. Cos -1 is cos inverse and tan inverse. Now, these inverse functions give us angles if we give it ratios. So sin, cos and tan gives us ratios if you give it an angle. So that's the inverse operation. Okay, so we're going to work with three special triangles. We call them Pythagorean triples, because they all have rational sides. All three sides are rational values. Okay, so some of you might recognize this as 3, 5, and this side should be 4. We will show it a little bit later on. So let's start with this alpha, beta, gamma. So we have the opposite side, the y, and the hypotenuse are, so we can use sine inverse of 3/5, which will give us, on the calculator we say shift sin 3/5, and that gives us 36.87 degrees. Okay, we want to work with this exact number, but it will take a long time to type it in. So I go and I store it so that I can use the exact number. Shift, store, X. It's at the recall button, the store. Okay, so now the X value contains that whole angle. So now we can find the value of X. Okay, so this X and that X will be different, just to make sure. So we have the adjacent and we have the hypotenuse. So I'm going to say cos of 36.87 degrees will be equal to X over R. A over adjacent over hypotenuse. Okay, so X will be equal to 5 cos 36.87 degrees, and that will be 5 cos, and I'm just going to use the X in its place to the whole 36 comma, all the decimals, and that gives me 4, as expected. Okay, now we can continue to the next triangle. So we have an adjacent, an X and an R. So we can say cos uses X and R, so it's cos inverse X over R, which is 12/13, and that will be shift cos 12/13, which gives us 22.62 degrees. I'm just going to store that in X again to replace the previous X, but I don't have to round off unnecessarily. Okay. Now I can say tan of 22.62 degrees is equal to y over 12. So therefore y is equal to 12 tan 22.62 degrees tan alpha x, which gives me exactly 5. Okay, and you can test that with Pythagoras to make sure. Now we're going to go to our last triangle. We've got an opposite and an adjacent, a y and an x. So therefore we're going to have to use tan. So tan inverse x or y over 15, so y over x, which will give us shift tan 8/15, and that's going to be 28.07 degrees. Okay, so now we have that. I'm just going to store it again in X, and we want to find R, and so far we've used cos tan, so I'm going to use sin for completeness. So sin of 28.07 degrees is equal to 8/R. So R will be equal to 8/sin 28.07 degrees, which will be equal to A divided by sin alpha x, which is 17. Okay, so there we have all the sides and all the angles. We can calculate those top angles pretty easily. Alpha, beta, and theta from 90 degrees. Thank you very much.